Here we're going to look at question 20 from section 2 of the BMAT 2018 paper. So in this question, we're told we have a bag of 20 sweets. The mean mass of this bag of 20 sweets must be greater than 10 grams, but not more than 10.5 grams. So we're then told that the first 16 sweets going into a bag of these 20 have a mean mass of 9.5 grams. Then the last 4 sweets each have the same mass, x. So what the question asks us to do is to find the range of x, the range of the mass values of each of these last 4 sweets. So if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it together. Okay, so the first thing we can do is summarise the information we've been given. We know that our 20 sweets have to have a mean of more than 10, but not more than 10.5. So when it says not more than 10.5, that means it could be 10.5. So we have to have this less than or equal to sign. But since it's more than 10, we have to just have a greater than sign. And then we're told about the 16 sweets and our 4 sweets finally. And we have to make sure that our mean of these total sweets lies within this range. So let's try and work out an expression for the mean of these sweets. While we don't have a value of the mass x, we could just try and use something. We could just use x, and then maybe we'll see how this expression could help us. So working out this mean, it's going to be 16 over 20 of 9.5. So this is the 16 sweets, each with a mean mass of 9.5 over the total number of sweets, plus 4 sweets which have a mass of x as a fraction of our total number of sweets. So of course we can just simplify this by extending our denominator across, so that it becomes 16 times 9.5 plus 4x all over 20. So why is this value of the mean actually going to be useful? Well, we could use it to help find our minimum and maximum values of x. So for our minimum value of x, then the mass has to be just large enough to bring our mass up to more than 10. So in this case, what we could do is set our mean to be 10 and calculate the value of x for this to be true. So let's just rearrange this. Multiplying by 20, first of all, makes the right hand side 200, and then we can take away our 16 times 9.5, giving us 152. And then dividing by 4 gives us x equals 48 over 4, which will cancel out just to give us x equals 12. So the mass of our last 4 sweets would be 12 grams each. What about though for our maximum case? So here the mean could be as great as 10.5. So if we set our mean to be equal to 10.5 grams, then we can do the same thing and just rearrange in a very similar fashion, multiplying by 20 and taking away our 152 before finally dividing by 4 to give us a maximum x value of 14.5 grams. So in this case, if the sweets were all 14.5 grams each, then our mean would be exactly equal to 10.5. And similarly, if our masses were all 12 grams, then our mean would be exactly 10 grams. So we have to find the range of values of x. Now our mean has to be greater than 10, so therefore this mass has to be greater than 12. But our masses here could be 14.5 because they could be, the mean can be 10.5. So bearing that in mind, we can just write our mean in this way, with our masses being greater than 12 but less than or equal to 14.5 grams. And this answer here is going to correspond with A given in the question.